Hey everybody, Michael Snyder, Worldwide Weather Watch. Today is March 3rd, first video for this new channel. Starting it off down under here in Australia, we have tropical cyclone Alfred. And in the Indian Ocean and down towards Australia, they're called cyclones. And when you get up in towards the Western Pacific Ocean, they're called typhoons. When you go off in towards the dateline and on through portions east, they are called hurricanes, and same thing for the Atlantic Ocean. But this one's going to push towards the coastline there, and I can imagine some of the dust devils that must form out across some of Australia. Look at the land largely free of clouds today, but it's kind of fun that you can look at satellite imagery all over the world. You can see the sun still rising across the Indian Ocean, and it's since set here where I am in the Pacific Northwest. But it's always interesting to look at the Bureau of Meteorology there in the Australian government. It's interesting to look at different government websites here, and you can see this brings a gale towards the coast and some heavy rain as well. So also interesting stuff. They do seem to have a lot of information here. So nice to see that. And we'll be learning this together, and I'll be kind of crafting a system of how I look across the planet for active things here. So we're going to go through this learning curve together at times. But look at this: meteorological and astronomical seasons in the southern hemisphere. In the across North America, of course, we just moved into meteorological spring. But since they're going from meteorological summer, they've just now entered meteorological fall. They'll be in astronomical fall as they go towards March 20th there. But yeah, coming out of summer to fall, and then eventually winter here across the southern hemisphere is incoming. If we take a look up across Russia, Siberia, some very cold air spilling off here. Look at this mid-latitude cyclone. And you can imagine, all the heat that builds up across the western Pacific Ocean. This heat moves up in a current, this very warm water. And you can imagine interacting with that very cold air coming off Siberia. That's why the Aleutian Islands get some of the biggest mid-latitude cyclones on the planet. And yeah, so we can get some really big storms out there. I mean, this is a fairly deep low, but it's nothing compared to what can develop out there. And, you can kind of see the intertropical convergence zone there. You see some of these thunderstorms firing up on a daily basis. Also, it's a pretty chilly air mass that moved across China here recently. And there's also going to be some snowfall coming across portions of northern Japan. But if we take a look at that storm system that I showed you, there's again the Aleutian Islands. You got Russia back over here, and you can see North and South Korea. There's Japan. But if I put that into motion, you can kind of see that cold air spilling off the continent, feeding that mid-latitude cyclone there, and the chilly air bouncing around the continent that is Asia. And then if we take a look here at 2 meter temperature anomaly, I mean, even for Russia standards, it is very cold out there. This is the anomaly in Celsius. But yeah, you can see that pretty chilly air bouncing around out there. And there is going to be some warm up eventually here as we go on into this week. However, now, wider view of things here, this is the entire Pacific Ocean, or almost. You can't really see South America to the right. But there's Australia, there's Japan, there's the Pacific Northwest, and there's Mexico here, Hawaiian Islands kind of top center. If I put this into motion, the 24-hour running precipitation totals shows a tropical cyclone Alfred moving towards the coastline. Some very heavy rainfall and kind of a narrow band there. Not so narrow even. It looks like that on the map here, but some pretty heavy rainfall amounts. And then you can see the mid-latitude cyclones moving across the northern Pacific Ocean, the intertropical convergence zone, and yeah, this deep convection that always fires up here across the maritime continent as well. So kind of fun watching that. If you just kind of loop it through there through the 6-day period or so, you can see the 24-hour running total precipitation inches across much of the Pacific Ocean basin view here. And if we take a look across Atlantic Ocean, you can see this. Check out the intertropical convergence zone, quite active here between Africa and South America. And also notice this back across the lower 48 states. Look at this storm system. That's the severe weather happening here as we go through tomorrow across some Louisiana, Mississippi, and Arkansas. On the back side of that, there's going to be a blizzard. And there's also some much needed rainfall across some portions of the East Coast here, which fires have been burning. Now, speaking of which, across the south here, there's the enhanced risk. This is for tomorrow. And if I click on the tornado, you can see this hatched area. That means there is a chance for strong tornadoes. That includes Jackson there and some portions of Louisiana, it looks like, and Mississippi, and all the way back up in towards portions of Oklahoma, even that 10% does clip. But the hatched area is where you're really looking for the stronger potential for tornadoes. You also see there's a pretty significant wind risk as well. Hail threat, not as severe as tornado or wind. And if we take a look at that, the red is for the blizzard warnings of this mid-latitude cyclone. So yeah, big severe weather coming, blizzard on the backside, meaningful rainfall for the East Coast. And if I put this into motion, you'll see this textbook mid-latitude cyclone. This is where the severe weather is, down here in kind of the southeast quadrant of this deep low. And you can see again the very cold air back behind across Nebraska, moving down into Kansas, portions of Missouri, Iowa, Minnesota, and Wisconsin as well. Again, just a textbook mid-latitude cyclone swooping across the Great Lakes. Big trailing cold front all the way down through Florida, and snow all the way back up across the Great Lakes and up into Canada. So let's take a look here also at total precipitation across the Indian Ocean. And there is actually another tropical cyclone here down to the south of Madagascar. And you can kind of see the intertropical convergence zone also across the maritime continent and across portions of India. You can see we are not in the monsoon season as of right now, but that is coming up here later over the next few months. And we'll be checking out that at times as well. And so this is the European. So this is, I believe it's pronounced Hyundai. Someone correct me if I'm wrong, but this is something cool you can look at. You can look at the European or the GFS, and you can check out these tropical systems all around the planet. And you can kind of see how forecast their strength is going to be and just the general direction of their movement. Now, here is an equatorial view of basically the entire planet. You can see the Mercator projection here kind of makes things a little bit discombobulated. These are not represented properly here. You know, these are distorted quite a bit. Alaska is not that big compared to Mexico. Greenland is not that big compared to, you know, North America and whatnot. But you might have learned about that in your elementary school geography class. But let's continue on. And I'm going to scroll through here, and you'll notice something about the equator here, where that is where the deepest moisture resides. You know, the much thicker air mass as well. So you got that deep convection, and you see these bouncing around here, what look like convective outflow boundaries. That's that deep convection. And when it rises up and then collapses and drops back down, those outflow boundaries go rushing across the ocean, and they'll bump into other outflow boundaries, and they will create additional thunderstorms. So you can see the gravity waves moving through the precipitable water there across the equatorial Pacific and the Atlantic Ocean and all over the place here when you're in the tropics. And you can also see the atmospheric rivers as they extend north towards the Aleutian Islands, up towards Western Canada and the Pacific Northwest and whatnot, and across the Atlantic Ocean as well. So if we take a closer look at that now, I want to pay attention to this one there. You can see the outflow boundaries and the gravity waves bouncing around the Pacific Ocean there. And how do we know those are thunderstorms? Well, we can check the lightning flash density potential on the European. If we scroll through the same time frame, look at those thunderstorms and the outflow boundaries just kind of racing around the Pacific Ocean there. So fun stuff. And you can imagine these outflow boundaries, they bounce into each other and they get convergence and they rise up and they form new thunderstorms and they tap themselves out and they drop other outflow boundaries. And these are just non-stop clouding moving around. So you can imagine being out across some of these remote islands in the Pacific Ocean, some of these outflow boundaries moving across your region. Now, if we take a look at the 2-meter temperature, very interesting here. You can see how cold Antarctica is. I mean, look at this, -54 Celsius versus 43.2 Fahrenheit, which is, up over 105 degrees Fahrenheit. And that's probably some portion of Africa there. You can see South America and some pretty warm areas as well. And you can see some cooler temperatures there across Greenland and for Russia as well. But if I scroll through that again, you'll see the gravity waves there across some of the deeper convection across the Indian Ocean, Pacific, and the Atlantic Ocean there. And yeah, you can kind of see these temperatures bounce around. And you notice the land masses, they heat up and they cool down much more rapidly than the oceans do, because the oceans hold much more heat. They're much less susceptible to those big diurnal and nocturnal changes in the temperature. So fun stuff there as well. And I talked about that Mercator projection. If I click on that, you can see how Antarctica is really relatively pretty small. But when you're looking at it in this projection, it just looks absolutely monstrous. Same thing with Alaska and portions of northern Canada all the way up into Greenland as well, and portions of Russia really get distorted as well. But there's also this stereographic here, which you can look at on the European website as well, the weather bell. So you can kind of see that it can distort things bigger on the southern end of that as well. But other things I'll be looking at is like the World Meteorological Organization. I'll try to get some data from here, and we'll be going over things on a daily basis. But I'll kick this channel out or this video out for now. I can tell I'll have some work to do to get my workflow down and to go through this on a daily basis. There's so much to look at, and I'll be going over certain events. I'll try to find like warmest places across the planet, coldest places, where the snow events are happening and whatnot, and we'll watch the change of season, and we'll just cover some fun stuff here across the planet. But otherwise, what else? I'll kick this video out now. I'll do my normal briefings tomorrow for both California and Pacific Northwest Weather Watch. I don't know how often I will do this. I'll try to do it. If I can, I'll do it every day. So we'll see how that goes. But yeah, anyway, hope you guys are having a good night. Click like and subscribe. Let's see if we can get this channel up over 1,000 subscribers by tomorrow. And I will talk to you guys later.